If you're not familiar with potential energy or kinetic energy, I recommend that you read the background that is posted in Echo. But if you are familiar, then you'll know that the equation for potential energy is equal to the mass of the object times acceleration due to gravity times the height that the object falls. Kinetic energy, the equation is 1/2 the mass of the object times its velocity squared. Now the velocity is squared, not the entire expression. And total energy is just the total amount of energy in the system, whether we have a portion of it being kinetic, another portion being potential, another portion being heat due to friction, doesn't matter. The total energy of the system can be added up by taking each of those portions together. So we'll do a few problems to illustrate that. First, I have a person with a rock at the top of a cliff, and the mass of their rock is 5 kilograms, and the cliff height is 200 meters. So we just fill in the equation, potential energy equals a mass of 5 kilograms times the acceleration due to gravity, 10 meters per second squared, times a height of 200 meters. So I've got my 5 times 10 times 200 gives me a potential energy of 10,000 joules. It's that straightforward. To do kinetic energy, here I am in my dream convertible waving at you all, and the mass of the convertible is 3,500 kilograms, and I'm cruising down the freeway at 50 meters per second. So what is my kinetic energy? Well, I take kinetic energy equals 1/2 the mass, which is 3,500 kilograms, times 50 meters per second, and I'm going to square that value. So I do that, 1/2 times 3,500 times 50 squared. This gives me a lot of energy, which would make sense. I'm cruising down the freeway. 4,375,000 joules. So let's look at total energy for each of these problems and add some parameters to them. So here I have my potential energy problem, same problem, my original potential energy at the top of the cliff before I dropped the rock was 5 kilograms times gravity times 200 meters, which was 10,000 joules. Well, I want to know how many joules of kinetic energy my rock has when it has reached this point at 10 meters off the ground. So what I can do is I can do potential energy equals 5 kilogram rock times 10 meters per second squared times that 10 meters off the ground. So 5 times 10 times 10 is 500 joules. So if I were to look at this rock right here at a height of 10 meters off the ground, it would only have a potential energy of 500 joules. But if I look at this equation, total energy equals the kinetic energy plus the potential energy, I'm going to ignore friction, so we're not going to have any heat energy in this particular problem. So if I want to find out what the kinetic energy is at this 10 meters, I would know that my total energy for the whole system has to be 10,000. So I would have, well, first I would have total energy equals potential energy plus kinetic energy. So I would have a total energy of 10,000 joules equal to a potential energy of 500 joules plus some value of kinetic energy. So I just have to subtract, and I would have a kinetic energy of 9,500 joules. What about the kinetic energy right here at this point, just a fraction of a second before it hits the ground? How many joules of kinetic energy do you think this rock is going to have right before it hits the ground? If you said that it's going to be 10,000 joules, you are correct. Because the total energy of the system is 10,000 joules. And so just a moment before it hits the ground, it would have 0 potential energy and 10,000 joules of kinetic energy. So let's go back to my convertible problem. I'm cruising down the freeway at 50 meters per second, and after slamming on the brakes for a few moments, I have slowed down to 25 meters per second. So how much work or how much energy was lost to the brakes? So I would use kinetic energy to find how much kinetic energy I have at that speed. So kinetic energy equals the mass of, well, hold on, 1/2 the mass of the car, 3,500 kilograms, times 25 meters per second, and I square the 25. So I do that. 0.5 times 3,500 times 25 squared. There is kinetic energy is equal to 1,093,750 joules. This is a 7. So how much work did the brakes do? Well, I would have to take that original value of, gosh, what was it? 4,375,000. So the total energy is equal to the kinetic energy plus the heat energy. There's no potential energy because I'm not off the ground any distance. So the total energy was 4,375,000 joules, and that's equal to 1,093,750 joules plus the energy that was lost as heat. So I use my calculator to figure that out. 4,375,000 joules minus 1,093,750 joules equals 3,281,250 joules. So this is the amount of work that my brakes have done so far. All right, these should help you get through some of the problems.